So we are going to actually get it right this time. Now, I messed up. That M does stand for maximum. I at least can say I did that part right, but it's not maximum of, it's maximum times. And if you remember in Cal 2, they had a silly little formula similar to this, where um, it was like y to the fourth. They don't do that. They do this kind of thing. Something like that. It was really dumb, and I forgot that was what it was. So I messed up. This is a max, but it's a maximum from one of these guys. So what we're going to do is find those, pick which one is biggest, plop it in as a number, and call it a day. So let's do that, I guess. So there's my F, and I think y'all saw this yesterday, but I'm just making sure that it's being recorded now. Um, yeah, that's what you get for staying after class and seeing me being foolish. So, yeah, I mean, that's all we're doing, just subscript x and y. So x, I get 2x minus 6y. Double x, I do just 2, don't I? So, yeah, it's okay. We're not hearing. It's fine. For y, I get a negative 6x. So for I get 0. But then from here, I can do xy, and that'd be the negative 6. So again, we're looking here, here, and here, and it's the absolute value, of course. Which one's the biggest is this guy, right? Absolute value, absolute value. So then what we're actually going to have now for this formula is 1 half times 6 times, and then they already give us the other numbers. So zero point 0.4 plus another zero point 0.4. Hello. And then all that squared. Time for the calculator. And here we go. No. Yes. What's up?
I do have one question.
Yes, please.
Would it also be smart to take into consideration we have f of y to take f of y of x as well? Or
We
is it
should. We should.
okay?
Yeah. I mean, that would be the same thing here.
Right.
And when we have the yx is equal to xy, again, I thought that I had done something about that at one point. I had talked about it. Whatever. It's a special thing when they're like this, okay, which is good. That's a regular thing. Um, so let's see, 1 half times the 6 times the 0.4 plus 0.4, all that squared. And their answer was, don't look. Yeah, you're already looking. It's being recorded, Chad. 1.92. So yeah, we're good. I just did it. I got the right answer. So a really simple problem in the end. It's just that I was
No,
no.
they never write anything.
Right, right. So we had to go to the book for this one. And I had to go and find out what that meant. I had not written this down in the workbook, and so that's why this is important to write down right now. So that was not in the workbook. Unfortunately, that's going to be a thing I do later. New revision and stuff like that.
That way you can sell it into the next group of students.
Yeah, yeah. Cool though. Any particular questions about how to multiply?
I think I need more help with addition rather than multiplication.
Uh huh. Me too. Me too. Calculator. Calculator. Yeah. Okay, I'm gonna scroll on. Let's do the whole thing over again from the very beginning. Actually, you know what? Y'all do this one. What do you think? Oh, you don't want to do it? You want me to do it? Okay, I'll do it. One yes means a yes. I like doing it. Let's go back to our formula. We got E is less than or equal to 1 half times M times this x minus x naught, y minus y naught, all squared. But this one's different because notice that we have x, y, and z, yes? So, oh no, my whole formula is changing. I don't know how I did not see this before class. It's not a big deal, right? We just add a z now. Woohoo. At least I hope that's the answer. I haven't really looked at it. But I think that's how it works. So we're going to figure that out. I almost feel like doing this one right now because this is the part that I need redeeming on, right? So let's do that. So I'm going to do fx to start with. Right here again is where I'm starting. What would I get for f sub x? Z. Yeah, it's just z. Yeah, that's kind of funny there. Okay. Let's do y while I'm sitting here. Negative 7z, very good. And then for z,
X minus 7y.
perfect. Now we're supposed to find double x, double y, double z, maybe some x, y, y, z. I don't know. We're gonna figure that out. We just want the maximum. And I'm thinking you can already see what's gonna happen here, like what the maximum's gonna end up being. Take a quick guess. What do you think the maximum is gonna be? 7. Oh my gosh, how'd you know? So yeah, but let's just make sure. So this is a 0. This is a 0. And this is a 0. So let's try some alternatives. Let's do x, y. So this in terms of y, 0. Let's do x in terms of z, 1. Let's do y in terms of z. And z in terms of y is the same thing. So out of all of these right here, what's is the biggest absolute value? 7. M equals 7. That's supposed to be an equal sign right there. Cool. And now from this, where does this plug it all in? 1/2 times 7 times, and they give you all the other numbers. 0.1. No. It's 0.01 plus 0.01 plus 0.05. All that squared. Are you trying to hide your calculator now? I mean, we all know you're super smart, but I can't let them see that I actually use it. It's funny. $0.1715. I do not know what the answer is, but I can go and check. I'm hoping that's it. So I'm going to flash the answer right quick. Hold on. And, yep, 0172. So yes, that's correct. We got it. Awesome. So there we go. We did it. Part B without any problems this time. I know. That was a clap. Thank you. I'll take that tiny little clap. Yes. Yeah.
There you go.
Thanks. Yeah, that's a Skyrim clap. I know, it's classic now. Anyways, so let me zoom out. Are y'all okay with the error part now? Yeah. Now that we know that m is like a number times something. Ugh.
Just a quick question. For linearization, just to clarify, it basically the same steps as before, but instead of by including also taking f of z into consideration as well, right?
Yes.
Okay.
That sounds great.
Okay.
Do that.
All right.
Actually, that's a great idea. How about y'all do the linearization part? That's an easy one. I'll sit and wait. I know y'all are already doing it. It's like in my notes, I can't have B before A, Chad. So you're laughing because it's true. Yeah. That's a good idea. That's why we have a workbook with cool formulas in it that are not always accurate. But you know what? Close enough. Yeah. think I enjoy this class too much. Do y'all think this is too easy? You're not saying anything. I do a serve. It will get more difficult. It will. It will. This is moderately easy stuff. I just feel like it's overly easy.
Just to learn the concepts, have some more easier things because the calculus too is a lot
Yeah.
harder problems where
Like-
I did not get as comfortable with
Right. The reason why.
yeah,
I know.
with the concepts. Yeah.
Exactly. No, I totally agree. And I'm expecting 100% pass rate for this class.
I'll try, but I can promise nothing and chill.
Yeah. No, I mean just by the fact that because it's a lecture class, y'all get to come in, ask questions, talk about it, that kind of thing. So yeah, you too. You're here too. It's good. A 100% fail rate.
That is true.
Say that again. Oh, it was an online class.
No.
So what now?
If she fails, you'll get 100% fail rate.
Oh, because you're in a different class? Oh, that's funny. Well, I don't know how CTC would view that. You're not going to fail. You're fine. I just wrote a letter of recommendation. You're not failing anything. Uh,
I can't do basic math.
Me neither, man. Me neither. I had this whenever I had the lecture class last time, we had 100% pass rate. So yeah, it's expected. I think you're at the level now where it's like you're now fighting for an A. That's what you should be doing. That's how it is going forward. Hi, Henry. I got 15 of them. Not enough. 10 more. Gosh, man, I'm so sorry. Can you send me an email reminder? It should be done with. I'm sorry. I figured I didn't know what I was figuring. Okay. Yes, that's what I was thinking. You would put them on the doors, but in that, do we have more than 15 doors? Of the wall, yeah. I can do that. You just remind me, and it'll be done. It'll be done today or tomorrow. But just send me an email. Thank you. All right. Oh, you want me to? Yeah, let's do the math now, huh? Now I've got yelled at for being so dumb. You did the wrong math, Chad. It was 25, not 15. So, anyways, so yeah, let's do some math here. So we need grad f, which we kind of already have, don't we? Z negative 7z, and then x minus 7y. And then we're supposed to do grad f at p. So then I'm plugging in the 2, 4, 3. So 3, negative 21, and then 2 minus 28. Is that going to be negative 26?
That's what I got.
Okay, good. Okay. So we plugged in our point and got some numbers, and this is my normal vector. That's also my slopes, right? The slopes to this. It's not a plane anymore, is it? It's hyperplane. I don't know. It's probably just a plane. Anyways, so from here, then we just go plug in the original, right? We need an F naught, I guess you can say. So I'm taking this and plugging it in directly. So just trying to do this rough. We got 6, and then we lost our math. So it's okay. Let's do this thing. X times z minus 7, y times z plus 2. And then I'm going to say x equals 2, y equals 4, z equals 3. Wow, Chad, you're so lazy.
I got it right.
Hey, there you go. And so then I guess my linearization, I'm just going to try to write it out right here. I've got 3. No. I always start with the constant, don't I? Yeah, negative 76 3, and then x minus 2, and then it's a negative 21. Y minus 4, and then I got a negative 26, z minus 3. That's my answer. Let's just see. Flash it. 3, 21, 26, 80. Would I get about an 80? Is it a negative 80 or positive 80? Positive 80. Notice that we're going to have two negatives make a positive. All right. I know you all say, like, well, I don't trust you, Chad. All right, fine.
Oh, that is correct.
It is correct.
Yeah, it does come out to be 80.
I got 92. Did I do something wrong?
You added a 6 instead of subtracting 6. Because it's positive 3 times negative 2.
Oh, yes. Yes. Thank you. Yep, there it is. Thank you. We did it. Woo! So that wasn't too bad in the end. See, that's the easy part, right? It's this error junk that's meh. Even then, it wasn't that bad in the end. Good. Okay. Let's keep cruising then. So I did this problem before class because it looked scary and I didn't know what they were asking for. And then I started doing the math and I was like, oh, this is so ridiculously easy. And I think if it's a coincidence or not, I don't know, but let's talk about it. They're wanting relative percentage of like change for volume and stuff. So if I'm going to change an X or a Y, then how much will its volume change eventually? You know, whenever you make let's do a 3D printing thing, right? You like 3D printing. So when you do 3D printing and you say, I want it exactly 2 centimeters, is it exactly 2 centimeters? You're like, yes. No, it's like 1.98 centimeters or something weird like that. It was a scaling thing. So if it changes, then how much does the volume change? How much does the surface area change, right? And that's what's going on here. They're wanting to say, hey, what's the percentage of difference? You know, its original volume and then dividing its difference so you can see what the percentage change would be. It's been like my it's off here by like they're saying like 0.5%. So then how much is the volume off? Is it off by 0.5%, 2%, 10%? Let's see. Does that make sense what the problem is? Okay, it's a pretty cool problem. And it's very applicable, not just for 3D printing, but like metal printing, or that's not a thing. For metal cutting, right? All kinds of stuff. Oh. It's called welding.
They actually have made metal 3D printers. It's just you can only run certain metals.
Yeah, I can see like lead. That makes sense.
Casting would also be a use case. You build a casting.
Oh yes.
You got
Oh, that's so right, because the heat will change its shape. Oh, are y'all in materials right now? That's what it is. There it is. Okay, so let's do some math here. What would be my volume of this shape? And be careful. Well, there it is. That is not an XYZ, that's XXY, right? So it's off by just a tiny bit. X squared Y. Now, they say dV. What does the D stand for again? Derivative. Exactly. That wasn't a mocking thing. It was just like, it's so
I know
duh.
what you meant, Chad.
It's like,
I know what you meant.
it's like D for derivative, duh. Exactly. Duh, D for duh. Anyways, I want to do this implicitly, right? That's why it's just dV. It's not saying V prime here. So when I start taking my derivative, I want you to see what you can come up with. Come on. I mean, you tell me right now. Don't go and do it. No, stop. You tell me. What would I start with here? Implicit.
Derive both the x and y.
Yes.
Start with x.
Okay.
2x, y.
Okay.
And then x squared. Yeah.
What do I put right here? X prime as good, or dx. But x prime is good. I admit it. I'm using d because I have a d here. Might as well keep with my d's. Yes. And then I have right here is a dy. Very good. Notice also that they have a dx and a dy here in a few minutes. Totally agree with x prime, right? That's what it is. But I'm going to keep with their Leibniz notation today. Very good. That is my implicit differentiation. Now, what my goal is to get this and to get that. And just like the last problem, I plug them in. Just like I did over here whenever they gave me these numbers, right? I just plugged them in. It was not a big deal. So I need to do that here. How am I supposed to take this and divide it by x? Right? Isn't that just bizarre? And because there's a plus sign here, it's really freaking me out. Yeah. So it's almost as if we need to look at the final answer. Look what they have here is they have this dv, but divided by the original v, which we have as well. Ignore that absolute value sign. That's just junk. So we do this, okay? And you might be thinking, Chad, that is actually not helping. And you're right, it's not. But watch what happens with this. So I'm just doing some algebra stuff here. We're just Leibniz zone, you know? This is fun stuff. Well, hold on. Can I like distribute and cancel? Right? Let me do a little bit of silliness here. Now, does this happen every single time? I don't know, honestly. I would hope so, because this is really cool. What's happening on this side over there? What's happening right here? Y's are canceling, and one of the x's is canceling. What about right here? Sweet. So what you have now, let me rewrite this. What I have, oh, you know what? I'm going to have some room for the next problem. Let me keep it over here. What I have now is dx over, it's 2 dx over x plus dy over y. Huh. Look at that, huh? We have those. I can actually plug those in. And so I have 2 times the 0.005 and then plus the 0.004. Calculator. Let's scroll that over. Calculator. And I got that number, which is the answer, by the way, 0.014. If I convert it into percentage, that's 1.40%. And that's what they actually wanted. I'll even prove it by going down and showing you my math. Yay, Chad. So I actually did prepare before class. That's a clap right there. Oh, thank you. I know, right? For once. And that's why I think this class is too easy, where I can come in, not prepare, and I get it right most of the time except for yesterday. So, you know, I told you before the class really got started, I was going to get things wrong every day. Way too easy. Are y'all okay with what was going on, though? Right? It's pretty cool. So now you already know what the answer is for the other one, but let's go through the math for it, right? So they say S. S stands for what? Okay. Capital S, though, is what? Surface area. What would be the surface area of this guy? Again, be careful. Plus x. 2x squared. The top and the bottom. Yes, very good. Yes, good. Yeah, 4 sides and top and bottom. Very good. So ds. Implicitly, what would I get now? Yes. Close. I'm going to put the dx on a second. We have more x to keep going. So yes. 4y, love it. And I'm going to do dx for both of them like this. But that is totally fine what you're doing too. That was all good. We would get to the same place. For my y's,
You
Yep.
get 4x dy.
just dy, yes, correct. So we're going to divide those guys. What I'm going to do is I'm going to divide them right now. Yeah. And if I was scared last time, I am super scared this time. Right? So this is ds over s, by the way. All right. Somehow I'm supposed to make this thing the actual same answer over here. Hmm. Any ideas?
Couldn't we factor at the bottom to pull out x? Well,
You're so clever. So clever. That's why I keep you around. So they both have an X. I can at least get rid of that. But it's still not perfect, but it's definitely getting somewhere. Look right here. It's almost canceling. Almost. Not quite, but almost. Oh, I see what you're doing. That's what you were recommending first. I should have just said, just followed what you had. You're exactly right. Let's do that. So you were definitely right. I was definitely wrong, and I will admit it. So split it beforehand. Thank you. That's good. Good thoughts. I like this. It's kind of like bleeding into the last one. All else fails, the answer is the same for the first and second one. So, but let's keep going. Oh, I see some stuff. I see it. This will be so fun. I'm going to use a different color to highlight what's going on here. Notice that we have dx over x, dx over x, and d. No, we don't.
cancel out one of those x's in the last one and just have 4 dy.
Well, that wouldn't make my paradigm happy. You're right. I could cancel those guys. So I'm thinking that there's something here, but then I don't see anything on this side either. Now, I did only prepare the top one, thinking, oh, the bottom one's the same way. But no, apparently it's way different. I'm going to go up and read to see if there's something else I can do. I'm going to erase that little dude there. I'm kind of not satisfied with him yet. Oh, now I got to fix him. Okay. All right, let me go read some. So we got these guys, and that's basically coming from these numbers. So they're a copy paste of that. I wonder if there's a way to get like the something we already had.
Out of curiosity,
Go ahead.
could we do something where we reorganize it so it's like dy over y equals 0.004? Couldn't we rearrange it so that we can get like a y variable or a dy variable? And plug that back in. See if we can simplify it even more.
Yes, I like that a lot actually. I'm thinking ahead here. If I were to do that, I would get a whole bunch of x's and y's still. And I have to cancel at some point. I mean, I get you. That would get rid of my dx's and stuff. So yeah, here's the proposal. Up here, we have dx over x is, I mean, I'm just going to say it's equal to this stuff. And then you can solve for dx by moving the x over, right? Same with the y. And then you could plug that in and get some more stuff here. So my x, I would have an x on the top here, an x on the top here, and then I would have a y right there. If I had an x and a y, these are like the same thing almost. They're like doubling themselves. So that might be something. Let's try it. Let's try it. So then I've got 4y, and I got 0.005x. Yeah, the 4 is for the y. And because they all have a common denominator, I'm just going to do that for a few seconds. Now, I'm going to say there's something wrong. I'm doing something wrong because this should have been way easier than all this. All with that common denominator. So here I've got xy, and here I've got xy, and I can mush those together, and then this is just an x squared. You know what? I bet this is going to work out. Watch this. This is going to be fun stuff. Okay, notice that we have right here x times y, and then there's a 4 there. Yes? And then we have a x and a y, and then there's a 4 here, right? So in a way, it's like I got the 4 times the 0.005 plus the 4 times the 0.004, okay? And so I've got this number in the front, xy, and then for my x squared, we got this guy. And again, all over my common denominator. But didn't we have something similar to that from the very beginning? Like, think about this for just a quick second. Did I actually change anything in my denominator yet? So I keep lugging this luggage around, okay, when it's been very unhelpful. All it is clogging my system. It's making it look really intimidating when I've only been really manipulating the numerator. I wonder if I go back to my original right here, and I wonder, here, let me get a new color here. Is this somewhat related to this? Do they look similar to you? Yeah, exactly right. They have something in common. What if, and this is just to think out loud, what if I can get my original and then I can like factor something out? Okay. Now, we're not good at this decimal factoring stuff because, well, I'm not, so you're not. So I need to somehow factor something out here, get back to this, and then they're going to cancel. Essentially, my goal is going to be to have blah, 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 and I cancel both the top and bottom, and I'll have a number and I'm done. Okay. That's my goal. So in a way, I'm going to say, what numbers do these numerator components have in common? Here. Right here, looking at this guy. What can I factor out?
You can factor out a
0.02. Yes, yes.
factor out an x.
What if I multiplied everything by like 100? That way I'm looking at like 36 and stuff like that. So 36 and 2, they both have a 2, that kind of thing. I don't know. But then again, I need to have it as a 4 in the front and a 2 right here. You know what? I feel like we're not used to these decimal factoring out thingies. Give me a second. I'm still writing down here, I guess. I want, okay, here. Let's just propose what I want here. I'm saying that there is an A number that is multiplied by 4xy times 2x squared, yes, is equal to this stuff here. This is my proposal. Solve for A. You get what I'm saying? There's got to be a way to do this easily, at least I hope. And this is going to be a decimal. I'm just going to go ahead and tell you because I already know the answer. It's a decimal. But we can figure this thing out. I really want to. So let's focus on this guy to here, right? If I want to get a 4 in there, it's kind of like I need to like multiply it by 4 or divide it by 4, you know? So let's see some options. So if I say times 4, and if I say divide by 4, okay. And on this side here, we need a 2. So divide by 2 times 2. Nothing's kind of lining up. Oh, do you see it though? Look, this guy right here, and then this guy right here, if you subtract them, you get your answer. Or no, well, you don't. You get something similar. It's 1.1.4 is the answer. We're getting there. Y'all are doing heavy math, and I'm just thinking here. Okay, well, I know the answer, so let me just try this. What if I did this 1, 4 times 4? Oh, no. Yeah, I don't think that's working. I don't know. I'm lost. Yeah, what's up? Yeah, of course. On decimals. Yeah.
Couldn't we factor out that 4 and try doing 0.9 or not 0.9 but 0.009?
And we have that down over here. Right?
Right.
That's interesting. Yeah. Let me start over. Y'all don't mind me getting it wrong, right? Correct? You're like, yeah, Chad, you should get it right every single time. Do you ever struggle with the homework? Okay. Do I ever struggle with the homework? Yes, I do. Yep. And I really thought that I had prepared enough for the day, but I didn't, apparently. This guy right here, let's start back at our original. And again, I want to get a divide by x in there. So what I'm going to do is I'm going to say x times this stuff, and then I'm going to divide it by x. You see what I'm doing here is that I'm multiplying it by 1, essentially, but I'm going to be able to get that dx there in just a second. So let's do this side over here. dy all over y. So then I don't want to cancel. What I want to do is say, like, these are my numbers. Okay, so I got x times 4y plus 4x, and then I got a y times 4x. No, hold on, I'm really close, Hold on. This one here is times the 0.005. And this one here is times the 0.004. Let me do this. I'm going to distribute this back in. So we got 4xy plus 4x squared times this. And here I got 4xy times this. Now I might be going down the same road. I'm not sure. But if I distribute this, I can get my 4x squareds kind of like pulled out. Yeah, go ahead.
When we originally did, I know we took both in derivative with respect to x and y, but I realized, did we do anything with the 2x squared part of the original x?
2x squared?
Yeah.
We got 4x.
But there's no y attached to it, and we have it in respect to dy. That's kind of where I'm getting a little confused.
Oh, right here. That's that one.
Yeah.
Right, plus 0 then. So like this, yeah, this is, I see what you're saying. But yeah, it's that.
Okay.
Right? Okay. Let's see here. And so then I got this guy here. Awesome. Well, what I want is like a 2x something or other. What if I start doing this? I'm going to give me a second here. 0.005 plus 0.004 plus 2 times 0.005. The answer is not 1.9, it's 1.4, isn't it? Yeah, okay. I feel like I'm getting really close. Well, there's that. How did you get that, Chad? I don't know exactly. I'm getting really close though. Like you're adding up these numbers here and you get this amount. But we already kind of knew that from the last problem. Hmm. 2 times that. No. Okay. I don't know. I'll have to look it up later. Or maybe I just delete it from the homework. What do you think? Yeah, we spent a lot of time on it. I'm going to move on. I don't know. But we did do the first part. I totally understand the first one. This one's just weird. I'll go and check it out later. For now, on your homework, it's the same number. For some reason. Great. Okay. I'm going to move on. I'm sorry. The correct answer is the same as top and bottom. They're the same answer. Yeah. I'm so close. I feel like I'm close, but perhaps. I'm not sure. I have to go back and check. I have to do the view an example. You know what? Guess what? I got that up. So let's go and do it. Not giving up. No way. So we're in 14, and this was 14.6. And this is probably near the end. I want to just, like, we can do the view an example or help me solve it stuff, you know? This is, that's the linearization. This is the one, look, it's the last question. Okay, so yeah, I know this is different, but if you remember, we're multiplying one of them by 2, and we're getting the right answer. So let me go back and see. We're saying that it's the first one times 2, and then the second one, because it is the same shape, it's the same everything else. So I'm going to do this one times 2, and then plus that guy. So let's do that. And I want to see. So clear all. It's brand new. Here we go. Times 2. And so percentage, you move it over, of course. It says 2 decimals. So yeah, that's easy. Is it the same here every time? Well, now you know. I'm not worried about you getting the right answer, okay? So now you know. It's not a big deal, but I want to know why. So let's ask my instructor. He might know. I know, right? Let's view an example here and see what happens. So, cool. Yes, we already did that. Why is this so tiny? Like, yeah. And look, I do this. I'm like, let me just see more of this problem. Continue, shrink. So dumb. Okay, so yeah, here we go. This is what we had, right? And then this is what we did. Oh, wait. Did they mess up? Let's just say they messed up and it's an S. Okay, let's just say it was a typo because obviously we're doing the S thing. Okay, well now they're doing S. Okay, so we had done that as well, remember? And we split it up. Okay, cool. So, okay, right, so that we get these. That's what we did. Okay. And you get the answer. I'm like, wait, what? Coefficient relative to this can be simplified by noticing the numerator must be smaller than 20. Okay. No. Oh, that's so frustrating. Yeah, I suppose. They're using inequalities to simplify it down. They're saying, well, obviously this is less than that, and here this cancels. Like, look at this. This is obviously less than that, and we get a 2. And here, obviously, by noticing right there. Oh man, that is so frustrating. Yeah, and well, here's the thing. They're technically right because of one small caveat, and I don't like this at all. I'm going to just tell you. See that alligator symbol right there? It's not an equals. So they can do that. And that's why we're having a frustrating time because there was not an algebraic answer. They simply said, you know what? Let's just call it quits. And we tried so hard, didn't we? I said, I know that there's a way to cancel the top and bottom, but we couldn't find that way. It's because they just said, nah, it doesn't matter. So I'm going to leave it on the homework for you to just basically duplicate the answer, okay? Now you know. But I want to maybe go do a little bit of homework. I mean, I know what happened now. Do a little bit of investigation. You know, not Wikipedia. They don't know what's going on. But I like Wikipedia, but they don't know what's going on here with math. They don't know math. So I don't know. Think about this for a little bit when you're driving your car. How can you do that? Why is that okay? You make a good point. I have stories about that, but I'm not going to record it. So, yes. Yeah. 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 Yes. Very similar. Yes. So now you know. We were doing it well. We were really close to an idea. I'm not going to super explain it because it's not a big deal. It's the last question. I don't really care. But good enough. Good enough for now. Good. Okay, cool. That was fun, and it's fun to see them use different things. They're not technically wrong, but it's frustrating. And we were definitely down the right path. We were so close. Okay. We got a couple minutes, and I do want to use every bit of time. So I'm sure you've seen local versus, and I'm not going to say just local, but also relative maximums and absolute maximums. Now, local is more specifically not an absolute. An absolute could be like a relative could be an absolute as well. So I'm not going to cross through local. I'm just going to say you might have heard that. And then we got minimums, of course, as well. How do you define what a maximum is? Is it says no greater than anywhere else around it? That zone around it is called a neighborhood, and that is an actual math name. So we're looking for the highest point in the neighborhood, the lowest point in the neighborhood. Yeah, it's a real math term. So um, there you go. Or basically, what would be the top of a hill or the bottom of a valley? Where would water pool up? You know, it doesn't have to be the bottom of the ocean. It could be somewhere, just a little lake, right? Okay, cool. How do you find these critical points? And there is a key word right here. Sorry for everything else in the way. Yes, it's f sub x equals 0 and f sub y equals 0. I cannot stress that enough. That is a key part to this working. If you don't have this, it doesn't work. You have to have the and. Have to. Now, what you're getting out of this is f sub x is going to be a big formula. And you got another formula. You got two formulas, and they both set equal to 0. What would you do? System of equations. Oh, you didn't say that. System of equations. Pull out a matrix? Yeah, it's a system of equations a lot of times. When you got to. So that, yeah, and that's why it's called a critical point. So that's a good one right there. And so they're talking saddles are what we've seen before, where the hyperbolic paraboloids and all that stuff, where it's not really a maximum, but it kind of is. It's not really minimum, but it is. Saddles are very specific, and there's an actual formula for it. This is not good enough. I don't like that. This is it. Like, I don't know if you can burn this in the brain. This is it right here. You're like, Chad, I have no cards for that. Yeah, like right here, I can't stress this enough. Both and, okay, they have to both be equal to 0. Once you have that, then you go and apply the second derivative test, essentially. And if you remember, and I know you do, it's always mixed up, isn't it? Your maximums are less than 0. Your minimums are greater than 0, right? I don't know. It's just the curve sketching stuff. Y'all remember that from Cal 1? It's been a long time. And this formula here, xxyy minus xy squared, this tells you if it's a saddle or something else. Notice that they're saying if it's greater than 0, this is a regular one. Here, it's a weird one. And then here, well, it's not just weird, it's fine. But then inconclusive is just who knows what. Okay, so let's do one. It says find all the maximum, all the minimums, all the saddle points. So let's do some math, I guess. I'm going to do x. And what would I get? F sub x.
2x.
Uh-huh. Perfect. And for my y?
X plus 2y minus 3.
Both. Both of those need to be equal to 0. How would you solve for x and y here? Yeah, matrix. Exactly right, matrix. 2, 1, oh. But you have to set it equal to that, so it'd be a negative 3. 1, 2, positive 3. RREF, you're good to go. Oh, wait, you can't use that on your next exam. Womp, womp, womp. Well, now I'm at a loss. Should I just let you use everything on the exams? Yep. Okay, well, I'll see you in 10 minutes. In the meantime, we're going to solve this thing. Yeah, so I'm going to solve for x down here by moving both of these over. And so what I have is x is equal to 3 minus 2y. And then I can plug that in right there. So 2 times 3 minus 2y plus y plus 3 equal to 0. Hi, it's good to see you. Distribute. Oh, I hate flat tires. I'm just playing with you, bro. I call it flat tire. What do you call it, flat tire? Really? No. Okay, sorry. You're being recorded. Do you want to say something you do? Reels? Hi. Epic, bro. Epic. That's funny. Go ahead.
No. I know you're still working it out. I thought you had like 3 equals y. I don't know why I saw that. Or negative 3. Yeah.
Yes, is that good?
Oh yeah, that's good. I thought you were just originally. I thought you were saying that. Oh, it was negative 3. I'm like, wait, hold on.
It is negative 3. Oh, okay.
I was talking for one.
We're good. We're good. So yeah, my point now that I got was negative 3, positive 3 for my xy. Now here's the thing with this point. It's a critical point. It could be a maximum, minimum, or a saddle. It can't be 2 of them. It can only be one of those things, right? How many points did I actually get though? Like, I only got the 1 point. Isn't that kind of weird? I mean, to me, that's weird. We're looking at a shape here, and if you look at the shape, actually, complete the square, blah, 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 it's a paraboloid. It's a paraboloid. So we're looking at a what? What am I actually going to get there? Oh my gosh, how did you know? Exactly. Let's go down and see. And it is a minimum. And there you're done. You're done. You're done. You don't have to do more. It can only be the 1 because it's only the 1 point. It's a minimum because it's a paraboloid. It's upwards. I mean, that was it. Now, how can we do this in the future when we have multiple points or a shape I don't know? That's when we do the second derivative test. We have 3 minutes. I mean, we can do that if you like. Let's do the second derivative test since we're on a roll. So then we got to do xx, and then we got to do yy, and then we got to do xy. So then xx, I already have my x. What's my xx? 2. What's my yy? 2 as well. And then my xy. 1, yep. So then the formula is xx yy minus xy squared. So I've got 2 times 2 minus 1 squared. 4 minus 1 is 3, which is greater than 0. What do I get when my second derivative test, blah, 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 is greater than 0? Let's go back up. And right here, we got greater than 0. Oh, well, it's a min or a max then. Okay, so we got one of those. Now that we've decided that it's going to be it's a max or a min, we need to use these guys to determine now which one. So I have to say, this actually comes first. What we did comes first. This comes later. Because see, the saddle doesn't have that. So if you had a saddle, why would you ever do XX? Does that make sense? Now that we have our result and it is greater than 0, so I'm like, okay, well, let's go back to xx. Well, xx is 2, which is greater than 0, thus minimum, right? It's always backwards. Greater is minimum, lesser is maximum. Good? Okay, good. So not hard. This is easy stuff. Now that we're past that silly little question there. I feel like we wasted a lot of time on that today, but that's okay because it was analyzing, right? Good? Thank you guys. Thanks for your patience with me.